This is a question from Kyle, who asks, if the Hubble telescope were aimed at the Earth, how detailed would the images be? This is a common question. The Hubble operators get it a lot, and their fact page answers it. The problem isn't as some people say that the Earth is too bright. As Phil Plate of Bad Astronomy pointed out, Hubble points at Earth pretty regularly to calibrate one of its instruments. The fundamental problem is that Hubble is too slow. Let me explain. Let's imagine we want to take a photo of this normal desk. Photons from the desk have to pass through all of the Earth's atmosphere, which can cause problems for ground-based telescopes, but for a space-based telescope it actually isn't much of a problem. The reason is geometric. If the distortion happens closer to the source, it can't mess up the image as much. The first small problem we'll run into is resolution. Hubble is the best visible light telescope we have, but its resolving power does have limits. Pluto, out in the Kuiper Belt, lies right at those limits. Until the New Horizons flyby of Pluto, the best pictures we had of Pluto were from Hubble, and they were pretty bad. To Hubble, the X-planet is little more than a mysterious blur. With Hubble's resolution and distance from the desk would look like this. Oh, I'm assuming the desk is beneath a skylight or outside, but the big problem is motion. Hubble is moving across Earth's surface at over 7 kilometers per second, which means that from Hubble's perspective, the desk is speeding by at 7 kilometers per second. Any reasonable length exposure, even with perfect resolution, would be completely blurred in the direction of motion. It's the same problem as driving along a highway and trying to take a picture of the ground passing beneath your car. Combining the two effects of resolution and motion gives us an end result that looks like this. That's no good. Could we rotate Hubble to track the surface and eliminate the blur? Well, Hubble routinely swivels to follow targets as it orbits. Usually, the targets are astronomical objects that are super far away. The automatic onboard tracking algorithms can at best handle targets as close as about 10 times the distance to the moon. When astronomers want to use Hubble to take pictures of the moon itself, they have to send it manual commands to rotate and then turn on the camera mid-maneuver. It doesn't work very well. The resulting photos are better than what you can see with the naked eye, but they're not very good by Hubble standards. Here's our desk, with the image degraded by a similar amount. Unfortunately, relative to its size, our desk is moving across the telescope field of view much faster than the moon. The strange thing is, the desk still really isn't moving all that fast. At least the angle to the desk isn't. To track the surface of the Earth, Hubble would need to rotate less than 1 degree per second, or around 1/10 of an RPM. But Hubble is simply too slow. It wasn't built for surface tracking. The telescope's top rotational speed is only a few degrees per minute, about the speed of a minute hand on a clock, and even those speeds are fast enough that its gyroscopes cause vibrations which destroy the image quality. Clearly, we need our own targeting control system. Hubble's rotational moment of inertia, similar to that of a small carousel, which isn't that big in an absolute sense. With our custom system in place, Hubble could be made to track the surface and get photos pretty close to its optimal quality, which means while Hubble couldn't read over your shoulder, it could watch you roll around on your desk chair. But this isn't just a hypothetical situation. Much of the technology in military spy satellites is believed to be similar to that of Hubble. So in a sense, pointing a Hubble-type telescope at the Earth's surface is not only possible, it's what the US government actually does.